Let us do question number 3. See Roman 1. We are required to get the approximate percentage change in the volume of a cylinder whose radius has been reduced by 3% and its height is increased by 2%. We are required to use binomial theorem. I would like to remind you about binomial theorem and how we can use binomial theorem to predict small changes in different quantities. And the binomial theorem states this: if you have for example 1 plus x, and you would like to raise it to power n, you get 1 plus nx plus n minus 1 multiplied by n times x squared over 2 factorial plus n multiplied by n minus 1 multiplied by n minus 2 over 3 factorial multiplied by x cubed, and so on. This will be the first term, the second term, the third term, fourth term. If now you want to get the fifth term in this expansion, it will be n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 multiplied by x to power 4 over 4 factorial, and so on up to any term you want to expand your binomial expression. If the value of x is so small, you are now squaring a very small value. In the fourth term, you are squaring, getting the cube of a very small value. If you go to the fifth term, you find that you are raising a very small value to the power of 4. So when x is so small, you are squaring it, we can ignore it in approximations. And I want to give you an example. If x is something like 0.02, if we square 0.02, we get 0.0004. Sorry, if you are getting the cube of 0.02, you get 0.00008. You find that the value of x in this case becomes smaller and smaller as you're raising it to higher numbers. So in this case, if we are doing approximate, we find that if I have 1 plus x and I want to raise this one to power n, then the first term we can retain 1. The second term here we can have nx, that's the second term. But when we go to the third term, where we are getting the square of a very small number when the x is small, we can ignore that because it will be a very small value. You end up finding that if I get a plus x, I raise it to power n, it is approximately 1 plus nx. So we ignore the other terms because they will be very small, as they are giving us products of very, very small value. Therefore, we have established that in a binomial expansion, if we have an expression 1 plus x, we want to raise it to power n, the value we are going to get is now approximately that. And let us now apply this idea in solving this problem. If you look at this problem, we are told that the radius of a cylinder is reduced by 3% and its height is increased by 2%. Then we are required to get the approximate percentage change in the volume. The change in volume, So the volume of a cylinder is equal to pi r squared, height, pi multiplied by radius squared multiplied by height. This is the volume before we change. Now when we change our radius and we reduce it by 3%, we find that the new radius is equal to 0.97 of the old radius, which we are writing as r, and our new height is equal to, we increased it by 0.2%, therefore it will be 1.02 multiplied by the old height h. The new volume before applying, after applying the change, the new volume will be equal to pi r squared. Our r is 0.97 r squared multiplied by our height. Our height is 1.02 h. So this is pi r squared height. That is our new volume, and our new volume therefore is same as pi r squared height multiplied by now 0.97 squared multiplied by 1.02 like that, and our new volume becomes pi r squared height multiplied by 0.97 is same as writing 1 minus 0.03 squared multiplied by 1.02. We can also write it as 1 plus 0.02. The purpose of doing this is we want to use binomial expansion to reduce this value from there to there, and also to multiply it with this other value there. So let us move on. So we want to square 1 minus 0.03 squared using binomial expansion, or rather binomial theorem. This one is approximate. We use the formula we have developed up there, that is we get 1 plus nr, that is we get 1 plus we get our n here is 2 multiplied by our x here, which is 0.03, and it is negative there. Therefore if we square this value, the value we get now is approximately 1 minus 0.06. It is approximately 1 minus 0.06, because 2 times negative 0.03 you get 0.06. Our new volume, then it becomes now approximately this is same as our new volume is pi r squared height, which is now approximately 1 minus 0.06. That is after computing the value 1 minus 0.03 squared multiplied by 1 plus 0.02. Our new volume, it is now approximately pi r squared multiplied by 1 minus 0.06 multiplied by 1 plus 0.02. Let us multiply it out, and we see what we're gonna get. Let us multiply these two binomials using approximations. So we multiply 1 multiplied by 1, we get 1. 1 multiplied by 0.02, so plus 0.02, that is 1 multiplied by 0.02, we get that. Negative 0.06 multiplied by 1, so you get minus 0.06. And when we come to multiply 0.06, negative 0.06 with 0.02, since these are two two small numbers, when the product of two small numbers will always give you a very small number. So let us ignore the multiplication of negative 0.06 and 0.02. Let us ignore that product. Therefore, the answer is approximately that. And therefore, this becomes 1.02 minus 0.06. And therefore, the new volume, it is approximately 1.02 minus 0.06. And this one becomes 0.96 pi r squared. Remember here you are multiplying with pi r squared height, and here you are also multiplying by pi r squared height. So that is our new volume, that is 0.96 pi r squared height. Now, if you compare this volume with now this other volume here, that is the volume before the change is pi r squared height. Now you find that the new volume is 0.96 pi r squared height over pi r squared height multiplied by 100. So we get it is 96% of, it is 96% of the old volume. So it is 96% of the old volume. There is a decrease. There is a decrease of 4% when the radius is decreased by 3% and the height is increased by 2%. So that is how we solve it. There is a decrease.